All right, hello everyone. Today we're going to be solving LeetCode 997, Find Town Judge. Feel free to pause the question and read it yourself, but I'm going to quickly summarize. All right, so in a town there are n people labeled 1 through n, and the rumor is that one of these people is secretly the town judge. If the town judge exists, then they must satisfy these two properties. The town judge trusts nobody, and everybody in the town trusts the judge except the town judge. There's exactly one person that satisfies both of these properties, and if they can't be identified, return -1. Now, how do we know who trusts true? We are given a trust array. And this trust array is just a series of arrays with two elements, and all it represents is the first element trusts the second element. And that's all it means. So this would mean that person 1 trusts person 2, and that's it. The person 2 doesn't trust anybody. So the town judge would be number 2, because everyone in the town trusts the judge except the judge, and the judge trusts nobody. In this example, person 1 trusts person 3, person 2 trusts person 3, and person 3 trusts nobody. So that would be, the answer here would be 3. Just for completion's sake, we want to go through the third example, and we'd say that person 1 trusts person 3, person 2 trusts person 3, so that would satisfy the second parameter. Everyone in the town trusts the judge except the judge, but person 3 trusts person 1. So that does not satisfy the second one, or the first parameter, and we return -1. All right, so I have this example case here, and a couple truths about the question. One is that n-1 people trust the judge. And what do I mean by that? It says that everyone in the town trusts the judge except the judge himself. So we just subtract 1 for the judge. So everyone else trusts the judge, and the judge trusts exactly 0 people. And let's say if we were able to give everyone some type of score, like a trust score. So first we're going to save a variable a. Let's just say that's our answer. So a equals n-1, which is 3, because we're looking at someone with a trust score of 3. And how the scoring system would work is, let's say something like this. Each person would have a score here. So like, let's say the first is how many people trust you, and the second number is how many people you trust. And we know this because the judge trusts 0 people, and we know that n-1 people, which is our a variable, they're trusted by. So if we go through and we check this, we'd say that 1 trusts 3, so that's 1 here. 2 trusts 3, so that goes up to 2. 4 trusts 3, so now the trust score is at our number 3. And 3 doesn't trust anyone, so they're at 0. But instead of storing both of these numbers, we could actually just simplify this. This could be simplified as the people that trust you minus the people you trust, which would be 0. And that would always just be a here. And we're doing the subtraction because let's say we had a number here, like 3, 1. So we'd get all the way here. Oops, I'm accidentally erased the wrong thing. Scallydraw just loves to act up sometimes. Anyway, so let's say we see that 3 trusts 1. So you trust one person, so now the people you trust score goes up. So we do 3 minus 1. That would be a score of 2. And as you see, our answer score is 3. And so they are no longer in contention to be the judge. And let me show you a quick rundown of what that would look like in code. Well, not in code. Let's just go example walkthrough. So first we'd get to 1. So we give everyone a trust score. So 1, 2, 3, 4. And every time someone trusts them, we'd add 1. Every time they trust someone, we'd subtract 1. So 1 trusts 3. So we're going to subtract 1. So everyone starts off at 0. This would be -1. And 3 is trusted by someone, so his score is at 1. Next, 2 trusts 3, so 3 score goes up to 2, and 2 score drops down to -1. Next, 4 trusts number 3, so 3 score goes up yet again to 3, and 4's drops to -1. And then let's say we were adding this last variable here, 3 trusts 1, so 3 score would drop down to 2, and 1 score would be increased by 1, so this would be a 1 here. And we check, does anybody have an ending score of A? That's no, because, so we'd return -1. But let's just say this wasn't here. So this last iteration didn't happen. We would see that 3 has an ending score of 3, and that would be our answer. Hopefully that made sense, and I'm going to show you how to code this up pretty fast. All right, let's see. So I think first we should start off with creating a variable called answer. So let's say answer just equals n-1. Next, we're going to say let tm, which would just be our trust map, equals an object. And we want to iterate over all of the trust scores, all the trust relationships, I mean. So let I equal 0, well, I is less than trust dot length I plus plus, something like this. Next, we want to create 2 variables. We're going to call person A, will just be the first person in the array. So let A equal trust I at the 0 index, and then we're going to do the same thing for B, but instead of the 0 index, we're going to go with the first one. So B. Next, we want to make sure to increment their scores accordingly. So we're going to say trust map equals trust map at A equals trust map at A. And if there is no value, we want to initialize it at 0. Something like this. And the A is the first person. So that means they trust someone. So we want to subtract 1 from their score. We're going to do the same thing for B. So at person B, but instead of adding 1, they're getting trusted. So we're going to add 1. And next, we want to go through and see if there's a person that has the key of answer, which is n-1. So we're going to do a for in loop. So for keys in tm, which is our trust map, if key, well, no, yeah, if trust map at key equals answer, return the key. And they want us to return an integer, so we're going to make sure to return the key as an integer. And if it gets out of this for loop and we don't find anything, we're going to return -1. And before we submit our code, we want to make sure to check the conditions, the constraints, to see if there's any edge cases. It says that trust length could actually be 0 and n could be 1. So let's say there's 1 person in the town. That means there would be no trust map because you need at least 2 people. So if there's just 1 person, we just should return 1, or we'll n. So if n equals 1, return n, something like this. And let's see, does this work? And there we go. We were able to solve this question pretty efficiently.